Welcome to this talk. We're going to talk. I'm Alex Ruiz. I work at Google. We're going to talk about Gradle in Android Studio 3.2 and beyond. We're not going to talk about the build system itself. What we're going to talk about is the integration of Gradle and Android Studio and how we're going to make the user experience of this integration better. And actually, here we have a tiny typo. There. So it's not actually 3.2. We're going to have these improvements in 3.3. We didn't make it on time to release in 3.2. And also, as part of this talk, I like to talk about the complexities and the challenges that my team faces that delay our work. This is the agenda for our talk. First, I'm going to give a quick introduction to talking about what my team does at Google. Then we're going to talk about Gradle Sync performance improvements. We are tackling this problem of performance from 3 different angles. We're going to talk about single variant sync, single Gradle invocation sync, and also unloaded modules. We're going to talk also about the project structure dialog, which is a UI where you can visualize the resolve structure of your project as Gradle understands. This means that you can see, for example, the dependency graph, something that you cannot visualize when you see your build files. We're going to talk about running Android and unit tests through the IDE, and also better project upgrades, better user experience when you upgrade components in your project. And then we're going to talk about what is my team's ultimate goal. So what does my team do? My team is a very small team. We're 7. We're distributed in Mountain View and London. And what we take care of is integration of Gradle in Android Studio. And this integration is very crucial for the IDE. Early in the days of Android Studio, when we started this project, we decided that Gradle was going to be the source of truth. This means that Android developers only need to configure the structure of the projects. For example, add modules or add source folders, add dependencies in one place only, which is the build files. Any IDE configuration files will be generated by the IDE when we sync with Gradle. Another problem that we wanted to solve was in the days of Eclipse, you used to get 2 build outputs, one from the command line and one from the IDE, because there were 2 build systems. Android Studio gave us the opportunity to fix that. And instead of having Studio build the project for you, what we do is we delegate the build to Gradle. So no matter where you build your project, command line, continuous integration server, or the IDE, you're always going to get the same output. So in detail, what does my team is responsible for? First, syncing a project with Gradle. This means that we connect to Gradle. We ask Gradle for the project structure. That means we want the list of modules in your project. Each module, the type, if it's an Android library, an Android app, or it's a Java library, it's a native C++ module. Also, we ask for the libraries your module depends on, and if there's in any intermodule dependencies. Also, we build projects with Gradle from the IDE by just clicking a button. We run unit tests and Android tests from the IDE. You just have to right-click a class or a package and say run tests, and the IDE will take care of running the test for you. You don't have to deal with the command line at all. The pre-structured dialog is a very special part that we're working on, and we're going to cover that in more detail. And we also have other bits of Gradle in the IDE that are very small and we're not going to cover in this talk. Gradle Sync, syncing a project with Gradle. Like I mentioned before, this is the process where the IDE opens a connection to Gradle, which is another process, via RPC call, and ask Gradle, this is my project, the location of my project. This is the Android SDK, the JDK. Please give me the project structure. And what Gradle is going to send us back is a data structure containing all the modules, libraries, source folders that each each of the modules in your project has. Again, Gradle is a source of truth, and developers only have to care about build files and nothing else. Gradle sync is blazing fast. Said no one ever. Can you please raise your hand if you think that Gradle sync is fast in your project? Really? Oh my God. Okay, I'm surprised. Well, yes. We know we are well aware of all the pain points that the Gradle integration that the AE has. We know that there's a lot of friction between these two components, and we're working on it. We know about it, but it takes time, and I'm going to explain why. First of all, technical complexity. This is the complexity that we like as developers. We want to solve these problems. We want to code. So Gradle sync is made of, integrates many parts. For example, first we have Gradle. We have the Gradle tooling API, which is the RPC that connects these two components, Android Studio. So I'm going to describe briefly how we do this. There are 6 big steps, but in reality, there are more than 80 steps that need to be done in a special sequence, and also they're dependent on context. So first, we have precinct checks. The first thing that we check is that there's an Android SDK and there's a JDK. Then we clean up the state of your project. For example, do we need to pass the HTTP proxy settings from the IDE to Gradle so Gradle can connect to the internet? Another thing is that does your project already has the Gradle wrapper? If it doesn't, we create that for you. Then, step number 3, we connect to Gradle using the build action. The build action is just a piece of code that contains the query for Gradle, and it's going to hold the results, and it's going to send that back to Android Studio. Then we have Gradle and the Android plugin, which is also a creation of Google, the Android plugin for Gradle. We retrieve the project structure from Gradle. We pass it through the tooling API back to the project. Those data structures are converted into modules, source folders, libraries. And then we take those modules and serialize to disk. And why do we want to do that? Because we know that Gradle sync is slow. If you close your project or you close the IDE and you open again, if we detect that there are no changes in between sessions, we don't want to go through another Gradle sync. We just load the cache model for you. So that was a very quick introduction. Now, this is the complexity that makes us delays everything. External dependencies. It has been great that Android Studio is built on top of 2 proven components, which is Gradle and IntelliJ, but also makes other things difficult for us, which is coordinating releases. It's very difficult to work with other departments inside your company. Working with 2 different companies, with different release cycles, with different priorities, in different time zones, is even more difficult. Sometimes we have code reviews that that take longer than we expected, or sometimes we miss a release of Gradle or a miss of IntelliJ, and we have to wait for the next release for our feature to be in. Now, let's talk about what we're doing to make Gradle sync faster. So the first thing is the IDE can only work with 1 build variant at a time. That's why in the IDE in Android Studio, you have that build variants tool view, where you can select the build variant you want to work with. The problem is that even though the IDE can work with only 1 variant, when we sync with Gradle, we sync all the variants in all the modules in your project. So it's very obvious to think, so why don't we just sync 1? Yes, that's something that we thought about more than a year ago. Actually, more than that. But it's not that easy. First, to do this, we have to add new APIs to Gradle, the build system itself, so we can pass parameters during Gradle sync. In this case, the parameter is going to be the selected build variant in the IDE, the variant that we want to sync. It took us It was our first contribution to the build system. Took us some time to actually understand a new code base. Took some time to have the code reviewed and have the pull request approved. But it was worth it. Then the next step was go to the Android Gradle plugin and consume those APIs so we can read the parameter that is passed to us and only sync that variant. Then, once that is done, we have to go to the IDE and use, again, the new APIs that we added to Gradle so we can pass the selected variants to the Android plugin. So the current status is we have end-to-end single variant sync. So it's working. Finally, we have this working. There are still some pieces missing. For example, we don't have Kotlin support. And why? In order for us to use new APIs from Gradle, we have to write our own Gradle infrastructure inside the IDE. For a long time, we've been relying on Ideas Gradle infrastructure. But Ideas is a general purpose Gradle integration. We want something that is optimized for Android. So we had to create our own. Also, that takes time. That new infrastructure by itself is at least 2 times faster than Ideas, and we're going to contribute that back to JetBrains. Now, we don't have Kotlin support because we have to write the Kotlin support ourselves. It's not like before that we get it for free from JetBrains. And at the same time, as we were writing the support, we realized that we need better models for Gradle. So we're also contributing that to JetBrains. So there's another delay. Now, this is the timings that we have for Gradle sync. So on the blue line is the current sync, the one that we're shipping right now in Studio. The y-axis has seconds, and the x is number of variants. You can see that with the current sync, as the number of variants increase, performance of Gradle sync also gets worse. But with single variant sync, it's a lot faster. Even for 100 variants, it's under 2 seconds. We still have, going back, we still have some, we can say some constant, that no matter how many variants you have, there's going to be a penalty there. And this is something that we're going to look after this. And this is mostly related to project configuration inside the build system. We need to also fix that probably in the Android plugin and also in Gradle. Now, I mentioned that we have project configuration takes time. This ties to the next point. This is the second strategy that we have to fix Gradle sync performance in the IDE. At the beginning, something very interesting happened. When people started using Android Studio, they were reporting that Gradle sync was very, very slow. And when we tried to measure the performance, we get numbers that were usually smaller. And we didn't understand why this delta, where this delta is coming from. And then we understood that what we think is Gradle sync is just part of the process of communicating with Gradle. So for us, all this time we've been thinking that Gradle sync was the process that we communicate, talk to Gradle, get the project structure, and apply that. But to our users, Gradle sync is that plus the source generation step that happens right after that. So it's 2 steps. So that explains why everybody thinks Gradle sync is a lot slower than that we think. Because they're thinking about source generation, which is another build that we're running after sync. And what happens if we do that? We are invoking Gradle twice. One time for Gradle sync, another time for source generation. And we're doing the same work twice. We are configuring the project, which is not cheap, twice. And we are resolving dependencies twice, which is not cheap either. And in practice, really, between source generation, between sync and source generation, nothing has changed. So we can do these 2 steps in one Gradle invocation and save a lot of time. The problem is that there are no APIs to do that in Gradle. We need to, again, go back to Gradle, the build system itself, and contribute these new APIs that we need. So the current status is that the design document has been approved. All this time we were waiting for the pull request to be approved, and actually yesterday got approved. Finally, we have all the pieces together. The next step is wait for the release. Well, while we wait for the release, we have to work on the IDE to use these new APIs. So when you sync your project, you're going to sync and instantiate a source generation in one Gradle invocation. That's going to save even more time. So we have Gradle sync, single variant sync, and source generation and sync in one Gradle invocation. That is going to make things a lot better for everybody. Next step, unloaded modules. So this is something that is going to benefit big projects. The idea here is that if you have a big project, let's say 50 modules or more, the IDE, not just Gradle sync is slower, but also the IDE, because there is a lot of source code to index. Indexing is another problem that we have to fix. But until that is a very tough problem. We've been talking to JetBrains to find ways to fix this. But until then, we have this, unloaded modules. This means that when you import a project or you open a project, you're going to see the list of modules that your project has. And then you're going to pick the modules you want to work with. Only those modules, only the sources of those modules are going to be imported into your project. The rest of modules, if they are needed, they're going to be imported as binaries. For example, let's say that you have module A and B. A depends on module B, but if in the dialog you just check A and don't select B to be imported, the IDE will import the sources of A, and for B is going to build B and link A to the build output of B as if it was another library. So you don't have the sources of B inside your project. This means that Gradle has less modules to sync, and also the IDE has less code to index. The current status is design ongoing. Like I mentioned, my team is very small, and there is so many things we can parallelize. We expect that by mid-year, we're going to start working on this. Now, that is the work that we have planned for Gradle sync. But the Gradle integration in the IDE is more than that. Something that we have heard from our users is that they have to manually duplicate what Gradle does in order to understand their projects. For example, I was talking a couple of years ago with developers from Yahoo, and they were telling me that they have an engineer dedicated just to figure out the dependency graph for their project. The project is so big that they need somebody to figure out what Gradle is bringing, what libraries is bringing, the transitive dependencies, the versions, if there were any libraries that were promoted, and that's a full-time job. The project structure dialog aims to do that automatically for you. So the main goal is to visualize the resolved structure of the project as Gradle understands that. So this means that it's going to be a UI that is going to display the data structure that we got from Gradle during Gradle sync. There you can visualize, for example, the dependency graph, the transitive dependencies that are brought by a single library. You're going to be able to see if, for example, you specify JUnit 4 and for some reason JUnit 5 came to your project, and who brought that? Why this library was promoted? Those questions that you have to pretty much guess now are going to be answered by this dialog. Another thing that this dialog is going to show you is how build variants are composed. For example, you have the product flavors, you have the build types, how these elements are combined, and which build variants are the product of that combination. Also, we want, probably not version 1, but in version 2 of the project structure dialog, we want to show you how a property of the variant was composed, because we have product flavors, we have the default config and build types, and how these properties got combined and resulted in the build variant. We want to show you everything, how Gradle computed everything, and what's the result of your build files in your project. And none of this information is trivial when you look at the build files. The build files only tell you what you want in your project, but not what actually happened after you sync with Gradle. A secondary goal is to be able to edit your build Gradle files visually. That is a noble goal, but not very realistic. Why? Because in order for a tool to understand your build files, it has to parse the build files. If projects stick to the DSL, to the build system DSL, it is very easy for us to parse them and have a model that is both readable and writable. But the moment that you have scripting, Groovy scripting or Kotlin scripting, parsing doesn't work. In order for us to know the result of that scripting, we have to run the build file as a program, and that's not doable at this moment. So probably for entry-level developers that are learning the DSL, this will be useful to edit your build files, but we don't expect advanced users to take advantage of this. Can you please raise your hand if you are using scripting your build files? I was expecting more, actually. Well, here is the tool. The project dialog was not ready for demo yet for this conference, but we're very close. And this is what we have here. For example, we have on the right-hand side, we have different areas of your projects. For example, you have the project level properties. You have SDK and JDK locations that are global to the project. Variables, we're going to cover that. If you have variables, if you want to use variables, for example, all the support libraries need to have the same version. Developers usually abstract that into a variable and use it everywhere in their modules. What we want to do here is to give you an easy way to edit your variables, create new variables, and also see who is using them. Then we have modules, which is going to be module level properties. That is work in progress. The one that I'm showing now is dependencies. If you look on the top, we have the module app. So first, you want to be able to see the dependencies that you explicitly declare in your build file. That's going to be in the center. So we're going to have app compat, the scope or the configuration compile. This is what you have in your build file. And on the right-hand side is going to be the dependency graph. Right now, we have it as a tree. So for example, we can see that for min APA 24 demo debug, that's going to be the configuration. You're going to have those libraries. And then if you open the node, you're going to see the transitive libraries that are brought by the libraries that you declare in your build file. Also, through this dialog, you'll be able to search. You're going to be able to add dependencies. When you add a dependency, you are going to be able to search the JCenter or Maven, whatever repository you have in your build file. Search, for example, you can type Wava, and it's going to give you all the versions available. You'll pick one, and also it's going to help you choose the configuration or the scope where this library should be added to. And this is something that is very tricky, because the name of the build variant usually doesn't match the configuration name. So usually it's by product type or by or product flavor or build type. So the dialog will help you figure out which is the right configuration for your libraries. The next one, at the bottom, we have suggestions. And this is where the project structure dialog in the background is going to search for new versions of your dependencies, and it's going to tell you there are some updates available. It's going to tell you that, for example, Gradle plugin version 2.1 is available. And then you can update just by clicking the button. It's going to give you some information about promotions. Some libraries were promoted. And that's going to tell you there some information about AppCompat 7, for example, was promoted from this version to that version. Also, what we like eventually for version 2 is to have lint checks here. Warnings and errors that you usually get when you open a build file, to get it here. Flavors and build types. Surprisingly, we got feedback from our users saying that this view is not as useful as the dependencies one. And this is where you can edit build types and product flavors individually. And then, again, on the right-hand side, you're going to see the result of that combination. Something that I want to show here is that when you edit, it's going to tell you the current value. And if you change it, it's going to give you what is the edit value versus the value that you got from Gradle. So this comes handy because if you, for example, let's say that debuggable was false, and then you change it to true, you switch context and come back, you don't remember if you actually entered true or was true. This is the variables view. In this view, you'll be able to add dependencies, edit dependencies, see usages of your dependencies, and not just simple strings. You can add variables that are maps and lists. Also, there's a very interesting example here. If you look at bar, the value that is in the build file is that string, com Android tools, lint checks, and then $version. Versions is a variable. And the column in the middle tells you what is going to be in your build file. And the column on the right is going to tell you what that variable that was embedded in the value of this other variable means. Also, as you type, you're going to get content assist of the variables that are already present in your build files, in case you want to embed them. And talking about variables, all the input fields in the project structure dialog are going to be variable aware. For example, in the second input field, there is the value beta. But if you hover over it, it's going to tell you that that value comes from the track variable. Last but not least, we get a lot of reports of users telling us they cannot run Android test through the IDE, especially Kotlin ones. And the problem is that we cannot run Android tests through Gradle. At the beginning, I said that our philosophy is to delegate everything through Gradle. But we cannot run Android tests because Gradle doesn't support that. We need to contribute support for running Android tests to Gradle. So this is something that we're working on now. So instead of us trying to build the class path, the same class path in the IDE as Gradle has it, instead we're just going to delegate test execution to Gradle. Another thing that we're doing is upgrading the user experience when you upgrade components in your project. So usually what happens is you upgrade to a new version of the Android plugin. You sync, and you get an error that you need a new version of a platform, for example. You change that, you sync again, and you get another error that you need a version of other component. And you have a few upgrades and several syncs until you get your project into a nice state, into a buildable state. And knowing that sync is slow, this is a terrible user experience. What we want to do is give you, first, fix all these errors automatically, if possible. If not, at least give you the list of errors all at once. So you fix them and you sync once. And the ultimate goal of this team is to remove the need for developers to click the sync button. That is extremely annoying. From the IDE, we cannot do it automatically because the IDE doesn't know enough about Gradle to do an automatic sync at the backend. Plus, sync is slow, and we don't want to tax your computer with doing several syncs while you're typing in your build file. So what we want to do is we want to go really deep into the build system and have a daemon that watches the build files in your project. Also, this daemon is going to be stateful. It's going to keep the state of your project, what Gradle sync extracted from Gradle, in memory. So when Gradle detects that there are changes in your build files, and this information is already in Gradle, Gradle will decide, Gradle with the help of the plugins, in this case the Android plugins, will decide if the last edit was meaningful enough that needs a sync. And then what do we want to sync? We don't want to sync the whole project as we do now. What we want to sync is only the parts that have changed in the background, and then stream those changes back to the IDE and apply those changes for you. Fast and automatic and invisible.